Hello everyone! In this video I would like to review configuration examples of STP topology tuning methods, specifically root bridge selection, port cost and port priority configuration. So let's get started. Today I'm going to use network diagram with 5 switches. All links between switches are trunk. Links between switches SW4, SW5 and SW3 are 100 megabits. I have two VLANs, VLAN 1 default VLAN and VLAN 2. PC1 is connected to access port on switch SW4 in VLAN 1 and PC2 is connected to access port on switch SW3 in VLAN 2. I'm going to use some methods to set specific switch to be the root bridge for specific VLAN. In addition to that, I'm going to review configuration of port priority and port cost. So let's go to configuration. This is our network. So let's first investigate spanning tree topology which we have at this moment. Switch 1, show run including spanning tree mode. And we can see that we have configured PVST spanning tree. Show spanning tree. Checking our network, we can predict that SW1 switch is gonna be a root bridge, because if we have all switches with the same priority, default priority, then the switch with the lowest MAC address will be the root bridge, and SW1 has the lowest MAC address. Show spanning tree, and here we can see that SW1 is the root bridge. It has a default priority 32,768 plus VLAN 1, we get in 32,769. MAC address of our SW1, all interfaces ports are designated, which is also showing us that this switch is the root bridge, because only the root bridge has all interfaces designated. Show spanning tree root, and we can see that our root ID, which is root ID of SW1, root cost 0, only for root bridge, hello time 2 seconds, max age 20, and forward delay 15. There is no root port because this is a root bridge. Let's go, for example, for SW3 switch. Show spanning tree. We can see that SW3 is not the root bridge for VLAN 1. It has root cost to root bridge 4, which corresponds to gigabit link, and it also has priority default plus VLAN 1. We get in 32,769. For this switch, G01 is the root bridge facing our root bridge, and this is root port with cost 4, which corresponds to gigabit link. Show spanning tree root, and here we can see our root ID of our root bridge, root cost 4, which is, as I've said, for gigabit timers, and root port G01. For this switch has also interfaces with cost 19, G02. I configured this port to speed 100. That's why we get in this cost 19. And now let's go, for example, to SW5. Show spanning tree. We can see that SW5 has cost to the root bridge 23, and this is because it has a root port G11 with speed 100 to SW3 switch here, and from SW3 switch to SW1 we have gigabit link. This with cost 4, so 19 plus 4 is 23. Remaining interfaces are blocked, and those are alternate. And so from this topology we can tell that SW1 is root bridge, all ports are designated, SW3 has G01 root port, these ports G02, 3 are designated, and SW5 has G10 G11 root port, G10 and the G0102 blocked or alternate ports, and SW1 has G01 root port, G02 designated, SW4 has G01 root, G03 and 2 designated ports. Now let's think why SW5 has G11 as a root port. This happens because if we have two links to the same switch, which is SW3, then and we have tie, then tiebreaker is port priority of advertising switch. SW3 is advertising switch, and G02 and G03 they have the same priority. So again we have tie, and next tiebreaker is port number. G02 has port number, let's see, show spanning 3. G02 has port number 3 and G03 has port number 4. So port number for G02 interface is less. That's why link G11 from SW5 to G02 to SW3 switch is in forwarding state, and all others are blocked. So let's think what we can do now for our root bridge in real world, in topologies where we have for example, you're not gonna have switches with default priorities. You would try to manipulate with which switch is best for you to be the root bridge, for example, for specific VLAN or VLAN groups, and you can make, like, if you have you can make, for example, one switch with the which is the best which has best performance to be the root bridge, and second one which has less performance to be the secondary, to minimize downtime in case something happens to root. So you need to have possibility to manipulate. With this one you can use commands, which I'm gonna show next, and for that one I'm gonna add VLAN 2 to each switch. VLAN 2 switch SW2 conf t VLAN 2 switch SW3 conf t VLAN 2 VLAN 2 switch SW4 VLAN 2 and switch SW5 VLAN 2. So let's see what we have now. So spanning 3. Now we have spanning 3 for each our VLAN, and it looks the same. It means that switch SW1 is the root bridge for VLAN 1 and for VLAN 2. I want to make switch SW1 root bridge for VLAN 1 and secondary root bridge for VLAN 2, and SW2 switch primary bridge for primary root bridge for VLAN 2 and secondary for VLAN 1. How can I do it? I can go to switch SW1 conf t. Let's check just first show spanning tree, so we can see that for VLAN 1 this bridge is the root, and for VLAN 2 this bridge is the root. Conf t spanning tree VLAN 1 root primary and spanning tree VLAN 2 root secondary. So let's see what we have now. Show spanning tree. So root primary configures priority for this switch to 24,576, and we have VLAN 1 plus 1 to make it root bridge, and it configures command root secondary configures switch to priority 28,872 plus here we have our VLAN to make it secondary root. So this priority is between 24,576 for primary root and the default one 32,000 show this 32,768. So now let's go to SW2. For SW2 I'm gonna use a little bit different command, conf t. So for this one we're gonna do spanning tree VLAN 1 priority. Here I'm gonna use priority. If you don't know exactly the number of priority because it has increment for 1096, you can type whatever you want and EOS will show you correct numbers. So for this one it's gonna be for secondary root bridge for VLAN 1, and that's why I'm gonna use 28,672, which is greater than for primary priority for primary root bridge for VLAN 1 for SW1. And spanning tree VLAN 2 priority, this one I'm gonna make the same which you priority which you get when you type root primary, 24,576. Let's see what we have. Show spanning tree. Now we have for VLAN 1 this is not root bridge, and root bridge is our SW1 with cost 4, and interface G01 root bridge again, and for example as for VLAN 2 for this VLAN this bridge is root. It has all ports designated, and show run interface G02. I just want to check. Yes, this interface is configured for speed 100 megabit. So with the help of these two commands, spanning tree VLAN priority and spanning tree VLAN root primary or secondary, you can manipulate which switch is gonna be primary root or secondary root for VLANs. So let's do, for now we have PVST running. Let's change to RSTP. I'm gonna start doing it from SW2 switch, spanning tree, mode, Rapid-PVST. And let's see what is happening here. Show spanning tree. You can see that now we have peer STP. So RSTP, at this moment we have SW2 switch running RSTP, and the rest of the switches, they are running PVST. So for this situation, a switch tries to establish an RSTP handshake with the device connected to the other end of the cable. If a handshake does not occur, the other device is assumed to be non-RSTP compatible, and the port defaults to regular 802.1d behavior. So what we can see here. So this port G01 facing our SW1 switch, and it is default to 802.1d behavior. And a G02 interface is in blocking state now. Oh, no, it's not in blocking state, in designated, it was still transiting to forwarding. So let's change conf t, spanning tree, mode, Rapid-PVST. Let's go to SW3. Conf t, spanning tree, mode, Rapid-PVST. Let's go to SW4. Conf t, spanning tree, mode, Rapid-PVST, and the last one SW5. Enables conf t, spanning tree, mode, Rapid-PVST. Let's wait, spanning tree. So now we have RSTP here and RSTP here. Okay, now let's try to manipulate with port cost. For example, on switch SW5 we have G01, G02 interfaces. G01, G02. Sorry, not for VLAN 2. Let's say for VLAN 2, G01, G02. G01 is root and G02 alternate. So I want to manipulate this cost on this port to change, to make G01 as alternate and G02 as root port. So for that one I need to either increase cost for G01 or to decrease for G02. Let's increase cost for G01. Interface G01, spanning tree, PGU filter, cost, and let's say 20. Show spanning tree. Now we can see that G01 is in blocking and G02 is a root, but it also affected the G01 interface on VLAN 1. Spanning interface G01, spanning tree, cost, spanning tree VLAN 1, cost, and let's do like this. Do show run interface G01, no spanning tree, cost, conf t interface G01, no spanning tree cost, no spanning tree cost 20, and let's do it only for VLAN 2. Spanning tree VLAN 2 cost 20. Show spanning tree. Now we can see that G01 port for VLAN 1 is not affected with this change, and for VLAN 2 is affected, and our G02 interface is a root port. Next, what I want to show is I want to manipulate with port priority. For this, I need upstream switch or advertising switch. For this link G02, G01, and for switches W5, our uplink upstream port switch is SW4. So let's go to SW4, conf t interface. Let's say what we have here. We have G02. I want to change. Let's change back conf t, because it's not gonna work if the cost is higher. We need to have the same cost, then it will be tie, and then it will go to the next one. So interface G01, no spanning tree, VLAN 2 cost 20. Show spanning tree. Let's see what we have now. Now we have our G01 interface back to the root, and let's go to SW4. First G01 is show CDP neighbor G01, and our SW4 switch is G02. So for G02 interface on SW5 we need to change G03. Let's go interface G03, spanning tree, VLAN 2, and then we have option port priority, and we're gonna change it to less than the default. Default is 128, so we're gonna change to 64. Show spanning tree. Let's check our changes, and you can see that it's been changed. Show spanning tree. Let's see what we have on our switch SW5, and we can see that now G02 is root port. It used to be G01 for VLAN 2, and now when we changed port priority on upstream switch, we decreased for VLAN 2 for port on SW4 switch G03 to 64, which is less than for the other one, so it changed root port on our SW5 switch to G02. The other feature for STP is PortFast. In some situations, transition port from blocking to forwarding state takes some time, and for some services like Pixie Boot or DHCP is not good. For these services, the port should transition to the forwarding state as fast as possible. There is a feature which called PortFast, which puts port directly to forwarding state, and that feature can be configured globally on the switch to all ports, and it will enable PortFast on the interfaces configured as access ports. So let's do this on our switch SW4 and SW3. So let's see what we have on SW3. Conf T. On SW3 our port G10 should be access port. Interface G10, switch port mode access, and this should be VLAN 2, switch port VLAN switch port access VLAN 2, and host the SW4 conf T interface G10 switch port mode access, and by default it is VLAN 1. Conf T spanning tree PortFast edge default. These ports which are called edge ports, and ports which are facing other switches and they are not facing like end devices like printers, computers, they are called non-edge ports. As you can see, this command enables PortFast by default on all interfaces. Let's see what we have now. Show spanning tree, and we can see that a G10 interface has type P2P edge. Show interface G10, and I'm sorry, show spanning tree interface G10, and we can see the type of this interface P2P edge, and we also can check it with show spanning tree detail section interface G10 no gigabit Ethernet 10 show spanning tree detail gigabit gigabit 10 section gigabit Ethernet 10. Yes, we can see that this port is PortFast edge mode by default. Conf T interface G10 spanning tree, and you can also enable on not globally on all access ports, but specifically on the port. So this command is spanning tree PortFast, and you can use edge. It's already enabled on this interface. Thank you very much for watching my video. I hope you enjoyed it. Please don't forget to subscribe to my channel with the notification bell on and show your support by hitting like button. I hope to see you soon in my next videos, but for now just goodbye and see you soon.